This is for 10.5. Today we are going to learn about the volume of pyramids and cones, which we did 2 of them yesterday with the volume of prisms and cylinders, because those were kind of related. Today you'll see how pyramids and cones are related to each other as well. But there are 2 warm-up questions here. We may just kind of briefly just talk about each one and then get started on the new stuff, because a lot of these are just more in detail. It does say choose one of the following problems to do, so at some point later between now and the next quiz or test, you may want to go back and try some of these out if we didn't do it in detail. The first question, it gives you actually the area of a trapezoid, because it's something that a lot of students do tend to forget. This is the formula for a trapezoid, which uses the 2 bases, because trapezoids have 2 bases, and then the height that connects the 2 parallel bases in a trapezoid. That h is different from the height of the prism, which in this scenario would be 10. So if you decide you want to try this problem out, you're going to start with finding the area of the base, which is a trapezoid. So these are possible type of prisms. This is called a trapezoidal prism, because it is it's a quadrilateral specifically for the bases, but the bases happen to be trapezoids. Okay, so if you decide you want to try this one out, find the area of the trapezoid that's right in front here. It's also the same in the back. Those are your parallel bases. You would use the 8, the 14, add them up, multiply by 1/2, and multiply by 4 for the height. When you get an answer for that, you're just multiplying it times 10, because remember yesterday, the volume formula is just capital B times H, or area of base times height, and you can finish this up. If you decide you want to try to finish this one, you will get 440 cubic centimeters. So I know I didn't finish that problem out, but if you decide you want to try it out for some extra practice, see if you get that answer when you're done. And of course the answer keys are posted on Canvas, that you can always check for all the worked out solution here. And now let's try the same idea, but for number 2, it talks about this pool, and a bunch of dimensions are given. It's like an oddly shaped pool, and it's saying that the water that's filling into the pool flows at a rate of 23 gallons per minute, and it wants us to calculate to the nearest minute how long it would take to fill this pool. So it's kind of more real-life based, and it even has a conversion here, because when you get your volume in cubic feet, we actually have to convert it to gallons so that we can use this rate of 23 gallons per minute. So again, we're not going to do this entire thing. Just to walk you through it though, what'll help is if you divide your shape, whatever solid you're working with, into the shapes you're familiar with. So for example, this right here is a rectangular prism, hopefully an easy one to see, and it gives you the measurements of 14 by 14 by 20. It happens to have squares for the bases, or you could use a different 2 rectangles as your bases, but regardless it would have to be those 3 measurements multiplied together, and you could call it like 1 and find the volume of that one. Then I can find the volume of another one, and if I outline this, you can see what shape it's forming, because it's kind of tricky at first to see what is that shape. It is trapezoid here, and if you look at the one in the front, here is the trapezoid that's parallel to it. So it's a trapezoidal prism again for this second solid that you're going to need to find the volume of, and then you would add it to like that existing one. And then finally, the third little shape there is this just rectangular prism again with the 4 by 20 by 14. Okay, so if you decide you want to try this one, I'll give you the final answer once you're, well actually, first you're going to find the volume to be 9,000 feet when you are, cubic feet, when you're finally done finding all 3 of them and adding them together. And then once you're done with that, you're going to do a conversion, because you want to convert it to gallons. How many gallons are you going to be working with? So this conversion will get you 67,324.5 gallons of water that needs to be filled into this whole swimming pool. And finally, you would divide that number by 23, because the rate is 23 gallons per minute. And finally, you'd end up with your answer, because it would take you, and it's honestly kind of odd that they're listing this in minutes, because it would take you 2,927 and you could round to whatever you'd like. It actually said to the nearest minute, so we'll round to 2,927 minutes. kind of weird, I know, to say your answer like that. You'd probably want to write it in hours instead if you divided by 60, and it would make more sense. Okay, so the idea here is you had a rectangular prism, a trapezoidal prism, and another rectangular prism, and you added the 3 volumes, then did some conversions and kind of finished it up there. So just a little outline in case you do want to try that one later on. This is what you can think through. Okay, so now let's move into the new stuff. What is the volume formula for these next 2? And remember, you don't have to memorize these. You will always be given the volume of a pyramid and the cone in addition to the ones you saw on Thursday. So volume of a pyramid and a cone, the reason we're doing these together is because they actually have very similar formulas. So if you think to the formula from yesterday, that's the the volume of a prism. Remember, it was this base, capital B times H, right? Capital B was the area of the base times the height. Well, if we wanted to look at a model, and there are YouTube videos and there's a bunch of explanations for this, but if I was to take a prism that had the exact same base as this pyramid, like if they exactly have the same base, let's say they're both squares, or they're both rectangles, or whatever it is, triangles, you know, whatever the base is, if they happen to be the same for the prism and the pyramid, what ends up happening is that you fill the whole pyramid with the amount of water that you would have, and you would fill up, let's say, you take that pyramid and you'd watch them fill it 3 times until they would fill up the prism entirely. So it's like saying that the amount of water that a pyramid can hold is 1/3 of what can fit into a prism. Okay, so that's the relationship. And again, I'll show you on Tuesday kind of like a video to explain kind of what it looks like. But here's the volume formula. Then as a result, it has this 1/3 in it. It's 1/3, and then it's just the capital B is the same and the H is the same, because remember that the volume of a prism, just to recap this, was capital B times H, or area of base times the height. But now we are saying that 3 of these pyramids, when I fill them up and keep pouring the water in from 3 times, doing the pyramid 3 times, it would fit into that of the prism, so that the pyramid is 1/3 of that volume. Okay, and again, you can try it out yourself, even if you want to see, does that actually work? It absolutely does. And so the models that I have in the classroom, you're welcome to kind of look at and see how, but it only, again, works if you have the exact same B. Capital B has to be the same in both those scenarios. And so still, B stands for the area of the base. And remember, the base can vary. For a pyramid, it could be a square, it can be a rectangle, or a triangle. But we are going to mostly stick to regular solids again. So we'll do squares and triangles mainly. But again, you may see other type of other type of bases as well. And then the H, remember, stands for the height of the pyramid. If you think back, though, from earlier when we learned about surface area for a pyramid, remember that we didn't use this height, we used the slant height. Well, now no longer are you using the slant height. So please make sure you realize that this H is not the same thing as L for slant height. So for pyramids, when we're looking for the volume now, we are not looking at slant height anymore. It's looking at just the height itself. Okay, and so we'll do, same idea actually happens for a cone. Because if you take a cylinder that has the exact same circle base, like let's say the radius is 2 for that cylinder, remember that the cylinder formula was, same idea as capital B times H, but remember it was pi r squared H, because the circle area was pi r squared, and H is the height of the cylinder. Well, for a cone, again, if you were to take a cone and fill it up with like water or some liquid and pour it into the cylinder that has the exact same base, you would fill it up 3 times. And that tells us then that the cone is 1/3 of the volume of a cylinder. So that's it. The relationship is literally that, 1/3 pi r squared H. And that's the next formula. We only have one left after this. But that's going to be all the formulas that we're working with now, and we'll try out some examples here. But again, something to keep in mind here is we do not use the slant height for the cone either. I know both pyramids and cones have like the slanted portion of it. We don't use that. So hopefully you're given the measurement for the height. If you're not, you need to calculate it. Let's say you give you're looking at a problem, it gives you the measurement for the slant height and the radius, well, you'll need to find the height then. Or if it gives you the measurement of the slant height and the height, but doesn't tell you the radius, you're going to need to find the radius because you need both the radius and the height, not the slant height, to help you do these problems. But again, it's being derived from the cylinder formula and the prism formula. That's why we did those first yesterday, so that now all we're seeing is it's 1/3 that much. Okay, and the same variables, R stands for radius, H stands for the height of the cone. Now I know we didn't do surface area of cones. We're still not going to do it. It's not going to be on the quiz or the test. You don't need to know surface area of a cone specifically, but we definitely do want to make sure we can do volume of a cone. All right, so let's try some of these out. The first one is a square pyramid, and what's kind of tricky on this first one is, and I'll leave the formula here so you can still see it, 13 is the slant height. This is L, not H. So I'm not ready to just plug everything in and be done. I need to work with this triangle instead, if it helps to just draw in the height straight down until it hits the middle there, and then continue it out this way. This is going to be a right angle, and I need to find this H. That's the height of the pyramid that I need to look for. So if I was to draw this right triangle here, 13 is the hypotenuse, and the two legs are H and this measurement down here. Let's look and see what that is. So we have 13 for the hypotenuse, H is the height we're looking for, here's the right angle, and the base here would be half this length of 10. So 10 is the full side, we're only going to the middle of that, so that's going to be 5. And this is actually a Pythagorean triple. If you remember, it was 5, 12, 13. If you can remember that, then you save yourself some work. Otherwise, you are using Pythagorean theorem here. 5 squared plus 13, H squared equals 13 squared. If you don't want to call it H because it's the same H here for the formula, you could actually have called it something else, like maybe X instead, because I don't want you to get confused with, it's not the height of, I said that wrong. It is the height of the pyramid and the height of the triangle in this one, so I'm going to actually keep it in H. So yep, at this point, if you solve this, you will find out that H is 12. And the units were not provided here, but we'll have to write our final units at the very end for the volume. Okay, we're ready to find volume now that we know that H is 12. We have volume equals area of the base is a square, so it'd be 10 times 10. And don't forget about the 1/3 in front. Remember, it's 1/3 times the capital B times H, and the H is that height we just found, which is 12. So good news is there's no decimals here, but the 1/3 will sometimes create a repeating decimal or just a decimal in general. This is when you type this entire thing in, you want to keep the answer either, it didn't say how to round it, so let's see what we get. 10 times 10 times 12. You can either divide that by 3 or multiply by a third, and you're going to get 400. So 1/3 times 10 times 10 times 12 will also show you the same answer. Okay, so 400 is our final answer here for the volume, and don't forget units, cubic units there, because it didn't tell me what the units were. Okay, so that's the first one. The cone, same idea on this next one. It tells me the diameter is 18, which means the radius is 9, and it tells me the height is 18, which is exactly what I need, and I don't have to calculate anything else special. So volume would be 1/3 pi r, which is 9, squared, and then 18 for the height, and everything's in miles. I'll write my final answer in miles as well, but we grab our answer. I'm going to show you an exact answer here because of that pi, and also a rounded one, since it doesn't specify how to round here. So if I'm going to do 1/3 times 9 squared times 18. I never wrote the pi in. Don't write it in yet. You get 486 pi, and the units were square miles, cubic miles, not square. This would be exact, and it didn't specify, so that's why I'm writing both. Next, we want to just type that into the calculator with pi, so times it by pi, and you get 1,526.81, or if you want to round to tenths, it's up to you. And then this is, again, cubic miles. This is approximated. Okay, so finish writing that part out just so you can see what the two volumes, the exact answer and the rounded answer, look like. Okay, and again, if you have questions on either of these, you can always bring them back. We'll go over it eventually as well. Now, if you go to the next page, it starts having practice, like the usual practice questions that we have. There's a lot of them that you're welcome to try out for practice. It does say on there that there's like a scavenger hunt. We're not doing it like that. So if you'd like to practice either on your own or with a partner, definitely feel free to do that. We have on like some of these, like number 1, we have not learned how to find the hexagon area. So unless you want to try a challenge out of like finding the area of one triangle in the hexagon and then multiplying by 6, that is up to you. But we will not have this kind if you want to skip this one. At least anything with hexagon, pentagon, or any of those polygons that don't have an area formula for yet. You could try the others though. Of course, there's some cylinder, cones. This one actually has a cylinder and a cone on top, so you should practice kind of that idea. This is a triangular pyramid. And then a couple more on the back. Some of them didn't print out totally, but we'll go over any questions that you may have on that on Tuesday. All right, so if you have questions, you can definitely bring those with you. You are welcome to either try out the practice now or work on the 10.5 homework, which is in that same packet that you got yesterday. And there is, let me double check, a front and a back, I believe. And then also you have a little exit ticket that you can also try out just for some extra practice if you'd like to. All right, and we'll go over everything on Tuesday.